In this video, we're going to be talking about tuples. It's one of the fundamental data types in Python, and you've probably encountered it quite a bit, and maybe you're wondering, well, what exactly are they? So tuples are a sequence data type. So they're very similar to lists. The big difference between a tuple and a list is that tuples are immutable and lists are mutable. That means that tuples really can't be changed and lists can. So here's a little bit of a snark alert. I have a little bit of a very short little rant here. You'll probably hear a lot of other people say that tuples are heterogeneous and lists are homogeneous. That means that tuples can have a whole bunch of different types of data, and lists should only have one or can only have one. That's totally not true at all. This is just totally wrong. And it's just a style that some programmers use. It's just a convention that's followed. That's not the way, that's not how Python works. When we read the docs, I think this may be partially what it's coming from, is lists are immutable and their elements are usually homogeneous and are accessed by iterating over the list. Now, we can debunk it really quick. I mean, you can just do this in your Python console right here. Here we've got a list here that we're making. It's got a number 66. It's got a string pig and just a generic object. And look, we can make that string just fine, or that list just fine. No errors thrown. So that is not the way Python works. It is just a convention or a style people use, and it makes sense a little bit. When you think about what do you do with a list? Well, generally a list is going to be iterated over in some way. And so generally those objects, those items in that list are going to have some kind of shared nature, right? Something that they all share. Maybe it's a property, maybe it's a method. There's going to be something in it that they share, but it does not mean that they have to be all the same. Lists are not homogeneous. When I was doing research for this thing, I just saw this repeated over and over and over again, and that is not true at all. So that ending the snark. So sorry about that, but just don't let people tell you that. That's not the way it works. Okay, so here we go. We're going to be creating a tuple. So there's two basic ways to do it. And so we've got our stuff here. This is the same one we used before with our list, but we're actually making a tuple with it this time. And so we've got 66, the string pig, and just a object. And here we go. So if we print it out, this is the way it looks. If you just print out a tuple, it gives parentheses instead of the brackets you will see with a list. And notice you just basically just give them each one of the elements just separated by a comma, and then you assign it, and then Python does the rest for you. You can also be a little bit more explicit and surround them with parentheses, which kind of helps maybe sometimes other developers. The Python doesn't really care either way. Accessoring the elements is going to be very similar. Like a lot of the stuff that you do maybe with lists, you're going to be able to do with tuples too. And one good example here is, here's our good old, we've been using this list for a long time, but we're making it into a tuple this time. There's a tuple of 3 different strings: circle, triangle, and square. And look, we can do just like as if so this is a tuple, but we can treat it in this way, just like we do with a list. We can access it by its index. So we're looking for index 1, so circle is 0, triangle is 1, and look, it works. Now we get into the thing of where it's different than a list, and we get into the idea of immutability. So if this was a list, if we had that shapes index 1 here, we could just change the value. Now if we do this with our tuple, so we got that same tuple from the last slide that has circle, triangle, and square. If we try to make index 1 be red, it's going to throw an error because tuples are immutable. So remember when we talked about that, the difference between lists and tuples, that lists are mutable and tuples are immutable. And this is what we're talking about, is that you can't change it. Once we've assigned it, we can't change it. Same thing with adding elements. Oh, this is a mistake. But yeah, you can't, this really shouldn't be here at all, but you can't add an element to it either. Tuples are iterable, just like lists. They're a collection of sequence data, so you can iterate through it. One of my favorite things are the iterators. So here we go. This is the classic one we've been using in a lot of our slides. Is we have our shapes, and then we can cycle through step through all these shapes and print them out, and it works just as you would expect. Tuples are also hashable, though lists are not hashable. and lists are, sorry, I totally messed that up. I'm so sorry. So tuples are hashable, but lists are not. And so we're going to do a quick little example here, specifically because they're immutable, that they can be hashed reliably. So we've got our shapes, and once again, that same tuple we created before. And we're going to create a dictionary called toys, and we can actually use the shapes. This here, we're going to use that actually as a key. So that's what we're talking about, is that it's hashable, and in this instance, the simplest way to demonstrate that is as a key to a dictionary. So hopefully that sense. So we might be wondering, well, why do you bother? You know, I don't see a lot of use for that. You know, I don't know how often I would be using a tuple as a key to a dictionary. That might be true, but tuples are faster than lists. So here we go. We've got like a little benchmark, and we can see that per loop here, it's 0.235, and this is for the list. See, we've got a list here, little brackets, and then we got a tuple here, and we can see that the list, the best of 3 is 0.235, whereas the best of 3 for the tuple is 0, or 0.046. So quite a bit faster, which is good if, you know, people care about speed. And here's a stupid tuple trick. It's not actually all that stupid. You'll see this actually quite a bit used, and I know it throws people off a lot. So you'll see this sometimes where, and people will oftentimes explain it a little bit funny, but what this is actually doing, so we have our fancy function here. So we're defining a new function called fancy, and it is just going to return this 1, 100. So what this is actually doing, when we remember that slide where we created the tuples, how you could create them with the parentheses or not, we're actually just returning a tuple here. That is because it's without those parentheses. This confuses people quite a bit. They don't understand that they're used to functions returning like one item of some kind, and it is. It is returning one tuple. It can be confusing. So hopefully, I tried writing this out, and hopefully you can see it. So here we go. We've got, and then we're going to call the fancy function, and then we can assign the values directly. So here's x, and here's y, and if we print them out, it will print out correctly. So you will see this not too frequently, but I see people asking questions and being really confused by this. So I hope that this example and my stupid tuple trick will help clarify things. It maybe not now, but maybe later when you see a function that is returning something that kind of looks like this, and you're like, oh, well, how do I know which one it's returning? Well, it's returning a tuple. So here's the tuple, and then we're basically just assigning it to a tuple, and then these are the values inside, and we can access those. Hopefully this video was useful for you. Thank you for watching. I hope that video was useful. If you liked it, hit that like button. And if you want to see more of these videos, please hit the subscribe button. And if you have any questions or comments, please leave those in the comments below. Thank you.